Okay, let's get started with an example. Example 1, find the area bounded between cosine of x and 1 minus cosine of x on the intervals 0 to pi. So first thing we want to do is graph these, so we can go ahead and do that. So there we've got an axis system. And then I would go ahead and, well, cosine of x we know how to graph. So cosine of x would look like this. And let's so cosine of pi over 2 is 0, so this is pi over 2, and then we would come back down. Cosine of pi is -1. There we go. All right, and then we have, so that looks like about pi right there. So let's label that. That's cosine of x. And it doesn't say what the functions are. We can just call this function f. So let's do f of x equals cosine of x. And then the top function is 1 minus cosine of x. So when you have a function such as this, cosine, if we multiply it by -1, right, ignore this +1 that we're adding. Let's just take a look at what is negative cosine. Negative cosine of x looks like this. It's going to be the same distance from here to here. So this is 1. So we're going to be down here at -1. So we're at -1. And it's going to be pretty much symmetric, just flipped. Imagine just rotating this graph, spinning it 180 degrees about this x-axis. Then we would get something like that. So that right there, that is negative cosine of x. But now what we're going to do is add 1 to it. Well, we know that adding 1 to it just translates upward. So 1 minus cosine of x, we would just translate this whole thing up 1. So let's go ahead and just move this down so we have a little bit of room. So this point here would move here. And this point here would move there. There we go. So, in actuality, if we draw this a little bit more to, not scale, but if I just kind of add in my axis that I'd like to have, there we go. So this point up here would be 2. This is 1. There's pi. And this would be pi over 2. Okay. So we want to know this area. That's the area. So our region here is certainly not vertically simple. So I'm just going to give a name here. Didn't do that yet. There we go. Let's call that g of x. So our region's not vertically simple. So this means we're going to have to use 2 integrals, because really this full region is really the result of gluing together 2 vertically simple regions. Okay, so we need to know what this intersection point is. That's what we need to know. So let's go ahead and figure this out. So in general, even if you didn't have a picture, we drew a picture because it's a nice exercise, and if you have a picture, it is a little bit easier because you have a little bit more to go off of. But if you didn't have a picture, and all you knew was the graph, the area between this function and this function between 0 and pi, you could still do it without a picture. The way you would do it is you would first find intersection points. on your interval. So on the given interval, if given. Sometimes they don't give you an interval. Sometimes they don't give you an interval. And that would be because the function naturally sections off a region. So I'm just going to erase that, though, for now. Let's just assume that they give you one for now. Okay, so for us, that means we are going to set the two functions equal to each other. So i.e., we're going to solve our two functions equal to one another on our given interval. So let's just assume it's a and b. But for us, we actually have specific functions in mind. So here, f is cosine of x. When is that equal to 1 minus the cosine of x? And we are going to solve this on 0 to pi. So we have 2 cosine of x equals 1. So cosine of x equals 1/2. And again, we can think of our unit circle. So we are only looking at 0 to pi, so that would be the top half of the unit circle. Here's 0, here's an angle of pi. So when is a function, so remember that cosine gives us the x value. So we want to know, where is there an x value of 1/2? Well, 1/2 is right here. So something I want to be really clear on here, this x here is not the same as this x here. Rather, it's interpreting cosine of an angle is equal to the x coordinate on the unit circle. So if we want to know when is the cosine of an angle equal to 1/2, that means where on the unit circle are there points whose x coordinate is 1/2. Well, that would be this angle here, which is pi over 3. Pi over 3. So this tells us that the angle is pi over 3. So this implies the angle is pi over 3. And that's where the confusion is. Here in this equation, x is being interpreted as an angle, where over here in this picture, when I said x equals 1/2, I was drawing the vertical line through the x coordinate 1/2. So I'm going to just erase this little piece here for now and say the angle is pi over 3, so x equals pi over 3. Okay, so this is pi over 3. Okay, now that we have that, we know that we're going to integrate from x equals 0 to pi over 3, and then pi over 3 to pi, we are just going to swap. Okay, so number 1 was to find the intersection points. Here we only found one. There is another intersection point, but it would happen down here when this line extends. So that would be well outside our 0 to pi angle. So there is more than, there's infinitely many solutions to this equation, but we're only looking here, so there's only one solution. Okay, so once you have that, step number 2 in this procedure is to determine which function is above or below, doesn't matter, because if you know the answer to one, you know the answer to the other. So you could do this by taking a sample point. So for instance, what we know is that our x-axis here starting at x equals 0, going to x equals pi, there is this point, pi over 3. So we need to know which graph is above the other. So for instance, what you could do is take a sample point. So maybe examine some point, pi over 4. And then you could plug in pi over 4 to f and plug it into g. So if you plug it into f, f is cosine, so cosine of pi over 4 is cosine of pi over 4 is root 2 over 2. And then if we plug pi over 4 into g, this is 1 minus root 2 over 2, which is 2 minus root 2 over 2. Yes. Might be useful to consider this to be a fraction here. Root 2 over 2 is about 0.707. So if we do 1 minus that, we're clearly going to have something that is about 0.3. So 0.3 is less than that. So this means that this number here, f, is greater than g. And if we look at our picture, we do have f greater than g. So that checks out. So you really just take a sample point in each little region and check to see which function value is greater. Doesn't matter what sample point you pick, because we know that the functions only touch here and here, so there's no way the function could possibly switch at any other place between here and here. So pick a convenient sample point, evaluate your function there, and that will give you tell you who's on top and who's on bottom. So you would do this for the remaining for the remaining region. Okay. So what we're going to do now is set up our integral. So let's pretend we figured that all out and we know which is on top. So then we're going to set up our integral here. So we would have the integral. So the area between the two curves is the integral from 0 to pi over 3. We just determined that f is above g, so we'll have top minus bottom. And then we know that from pi over 3 to pi, they swap positions, so g is on top and f is on bottom. So we would just swap the order of subtraction. So we can set this up. F is cosine minus 1 minus cosine of x, which is g, plus, running out of room, the integral from pi over 3 to pi of 1 minus cosine of x minus cosine of x dx. And then you can integrate from there. So if we integrate, this is going to be 2 root 3 plus pi over 3. For some of these videos, the main idea is to really communicate the new ideas, the new content, which is, in this case, the area between two curves. So how do we figure that out? All the intermediate stuff here, like these actual steps of integration, that's a Calc 1 integral. So for an already lengthy video, I sometimes take a little shortcut there. Okay, so that's the area between the two curves.